Hi everyone. I'd like to introduce Evan Cohen. He's an avid paraglider pilot and kite surfer and has been flying and kiting primarily in the San Francisco Bay Area in Canada for 10 years. Evan has flown numerous significant cross-country flights at several local Bay Area sites and has developed an aptitude for forecasting local weather conditions and choosing an appropriate flying site accordingly. Please join me in welcoming Evan Cohen.
Thank you. I hope so. All right, so today's talk is going to be about choosing where to fly in the Bay Area. And I do want to mention that this talk is really Bay Area specific. So I'm going to be primarily focusing on our local flying sites. But hopefully the knowledge that you take away from today's talk can be applied to other sites outside of the Bay, in California and elsewhere. So the goals of today's talk are to learn about typical weather patterns in the Bay Area, learn about the common conditions and weather patterns at our local sites, and from the first two, to hopefully independently make informed and safe decisions about where to fly and where not to fly on a given day. So a little bit about me. Martin gave a very short preamble, but basically I've been flying stunt kites and other types of kites since I was a little kid, pretty much as long as I can remember. I actually started paramotoring and snow kiting back in 2008, so about 10 years ago. About a year after taking up paramotoring, I discovered that I didn't actually need a motor to fly, and sort of taught myself how to ridge soar without the motor, and then took up kiteboarding shortly thereafter. 2 years later, I ended up moving to the Bay Area. In 2016, which was 2 years ago, I started learning how to do hydrofoil, which is a type of kiteboarding. And over the course of the last couple of years, I've had some pretty good success at doing some cross-country flights from several of the local Bay Area paragliding sites. And as Martin mentioned, I think I've developed an aptitude about choosing the appropriate site to fly on a given day, given the set of conditions, and that's some of the knowledge that I'm hoping to share today. So the agenda. First, we're going to start off with talking about the climate of the Bay Area, and specifically, we're going to focus on the topography and some of the microclimates of the Bay. Yeah, I realize that the font is a little small here. The other thing I want to talk about, which is very important to flying in the Bay Area, are the seasonal characteristics of the weather that we have here. The next thing we're going to go to is an analysis of several of the popular flying sites in the Bay, namely Muscle Rock, Ed Levin, Mission Peak, Mount Diablo, and Mount Tam. Time permitting, we will touch on Channing Hill, Sand City and Marina, and Windy Hill, but we'll see how much time is left at the end. The next thing after that is talking about some potential future sites, which aren't official sites yet, but I think based on some of the local observed weather patterns have the potential to be flown, and probably have been at some point in the past unofficially. And also time permitting, we'll go through a live forecasting exercise and try to figure out where it's going to be flyable tomorrow and maybe during the week if you're so lucky to be not stuck at work. Some things that are not going to be explicitly covered here. In terms of sites, I've intentionally excluded Blue Rock, and the only reason for that is because I personally don't have much experience flying there. I've only flown it twice in the last 7 years. There are better people to talk to about flying Blue Rock than I am, so go seek out the locals and ask for their expert wisdom. The other thing I'm not going to explicitly talk about are weather tools. So about a year ago, I presented a weather tools clinic, and the replay of that clinic is on my website, and I posted a link to it. However, I am going to make mention of a number of different weather tools which I use for figuring out what the best forecast is. And I'm going to make reference to them, so if any of that is kind of over your head, just go back and look at the weather clinic replay from last year. The third thing that I'm not going to explicitly talk about is site politics and policies. I recognize that in the Bay Area, not every pilot is eligible to fly every single site, just due to a number of long-standing reasons, and there are a bunch of stickers that are required elsewhere. But I think I'm indirectly going to talk about this because I've put a little bit more emphasis on Ed Levin, which is generally accessible to more pilots than some of the other paragliding sites and hang gliding sites. So hopefully, for those of you who aren't eligible to fly some of the other sites yet, you can gain some insights on what patterns to look for at Leavitt specifically. So the first thing, and I will admit that I kind of stole some of this material from my presentation last year. I'm not going to cover it in as much detail, but it's relevant background information for the more detailed analysis that we're going to talk about for flying specific sites. So the first thing is the climate of the Bay Area, and also looking at the topography of Northern California and how that interplay works. So when you take a zoomed out view of all of California and kind of look at the northern part, the thing to note is that we have coast ranges, and there are like 2 or 3 parallel ranges depending on where you are along the coast, that generally separate the cold Pacific Ocean from the Central Valley. And what that ends up doing is the Central Valley heats up significantly more than the cold Pacific Ocean, and that ends up creating a fairly significant pressure differential between inland and the coast. What ends up happening is, as the inland part of California heats up, the pressure lowers, and what ends up happening is you get daily sea breezes that generally form, which push or pull, as the case may be, this dense, cool marine air from the ocean into some of our inland sites. This is much more pronounced in the summer. It does happen in the fall and winter, and a little bit less so, if not at all, during the winter. The other thing to notice is that specifically in the Bay Area, there are a number of low points in the terrain. So the Golden Gate is probably the most recognizable. But even just looking from like the Golden Gate down to Marina or Monterey Bay, there's the San Bruno Gap. There are a number of other lower places. Monterey Bay itself is also a fairly significant break in the coastal ranges. And the thing to note is that in these places where the terrain is lower, the marine air has a higher tendency, or I guess it's easier for the marine air to be able to filter further inland. And it's important to keep that in mind. So zooming in a little bit more, let's just look at the Bay Area specifically so you can really see the Golden Gate, the entire bay. And you can also see the Sacramento Delta, which is basically this big gap where all of the marine air that's kind of pulled outside of the coast ranges is able to filter inland. The other very important thing to keep in mind is that the typical depth of the marine layer, which is roughly anywhere from like 800 feet to about 2,000 feet, there are variations in that, but that's roughly the average. The interesting thing is that the coast ranges that are separating the marine air from inland are roughly that same height. So Mission Peak, 2,000 feet, 2,400 feet, Mount Tam, 2,000 feet, the coast ranges, and Windy Hill is one of the sites that's around 2,000 feet. So the very interesting thing is we have this layer of air which is established over the ocean, and we have these mountain ranges which are mostly blocking that air from coming in, but due to the depth of the marine layer, it has a tendency to be able to funnel through those gaps and sometimes spill over, as the case may be. So if we zoom in even more, here's where things get even more complex. So if you look at the ocean side, you can see it's a pretty significant gap where the Golden Gate is. Let's say the air is blowing from west to east. It'll come through the Golden Gate, it'll fan out and kind of spread down the axis of the bay and also spread upwards and go through the delta. It'll get blocked by some of the terrain, but essentially what happens is later in the day, the marine air has a tendency to sort of fill into the valleys that are further inland, especially the East Bay Valley near Mount Diablo. But earlier in the day, very often, those valleys will actually be completely isolated from the marine influence. So timing is key to figuring out when to fly at certain sites. So the next thing to talk about are the different seasons that we have here. And it's sometimes joked that California doesn't really have seasons, and it's just it's warm and beautiful here all the time, which is somewhat true. I mean, it's what, November 2nd, and it was like 30 Celsius today. I mean, that it doesn't happen in that many places in the northern hemisphere. But we actually do sort of have 4 distinct seasons here. Summer, from a flying perspective, the characteristics of summer are persistent temperature inversions, where the inversion is roughly between 800 and 1,800 feet on most typical days. Microclimates really dominate the local weather here. So the coast is persistently foggy in the summer. It's generally hot and dry and somewhat windy inland. And we have daily sea breezes. So around 10, 11 o'clock, sometimes a little bit later, the wind ends up blowing through the Golden Gate and through the coastal gaps, and it gets fairly windy pretty much everywhere. I'm not going to talk too much about this, but there's a weather feature called North Pacific High, which is the semi-permanent area of high pressure, and that is generally what leads to the persistent fogginess that we have off of the coast, and is also what ends up, or what partially contributes to the daily breezes and wind patterns that we have, where there's fairly high pressure centered off of the coast, and there's localized low pressure that forms inland in California as the temperature rises, and you get that pressure differential that sort of blows all the wind in. There are some interesting occasional weather patterns that happen in the summer, which is where there's deep troughing. If you've ever looked at weather maps and you see the squiggly line which represents the jet stream, generally when there is a ridge, which means the jet stream is far up to the north, there's generally high pressure below that. If the jet stream dips down, there's generally lower pressure above that. Sometimes the jet stream takes a bit of a dip in the summer, which brings us relatively low pressure compared to what would normally be present in the summer. And what happens then is that the marine layer ends up deepening more than 2,000 feet. And we'll go through some examples and talk about a little bit about that later. But it's a potentially usable pattern for flying in the bay in the summer, which, as I mentioned here, is consistent but generally mediocre. You can fly every day, but it's probably not going to be that great. Fall is a really interesting time of year. So generally what happens is that the marine influence that's present over the summer starts to weaken. Generally the pressure starts to equalize between what's present in the Pacific and out in the Central Valley. Of course, what also happens is we start to get shorter days, which means the sun also starts to get weaker as it's drifting farther to the south. Sometimes, if we're lucky from a flying perspective, we'll actually get the first Alaskan lows and storms starting to push through the area, or at least start to get clipped by them, even if they don't influence us directly. The other thing which has been present for the last week and is going to be present probably for the next little while is we start to get offshore flow, which is present later in the season. Our typical weather pattern in the summer is winds blowing from west to east, but what starts to happen is sometimes these areas of high pressure set up inland, and the pressure is relatively low compared to the pressure inland, and we actually end up getting east or northeast winds. Another interesting pattern which starts to happen around the fall are these systems called inside sliders, which is basically a low pressure system that ends up setting up to our east. Low pressure circulates counterclockwise, high pressure circulates clockwise. The Bay Area, Northern California in particular, end up kind of getting sandwiched in between them. And what happens is you get this really strong north to northeast flow, and it just ends up making things really, really windy in the Bay Area. And today was actually sort of an example of that. There isn't very deep low pressure to the east, but we have been under the influence of this kind of north-northeast flow. In autumn, there can actually be some really excellent local flying days. Historically, they seem to be focused around mid-September, early October, and it's kind of this interesting combination of still having good solar heating or solar insolation, which gives us a good lapse rate, good heating at the surface. That marine influence is weakening, and if we're lucky, we actually get some cold air that's coming from some storms that are passing in the area. So the next season is winter. In the Bay Area, that basically means the rainy season. What happens to the marine inversion or the marine layer? It often just gets completely wiped out. The reason for that is because an inversion basically means that there is hot air that is pulled above cold air, and that basically makes the atmosphere stable. If you have hot air above, cold air below, it doesn't mix. What happens in the winter is that that's kind of the opposite scenario, and that's generally what would be considered to be a normal scenario in most other areas of the world, but just because we're so close to the Pacific, which is very cold in this area. It's generally inverted a lot of the year, but in the winter when we have these cold systems that are coming through, we actually start getting convection and we start getting clouds, and it can actually start to become unstable in the winter in spite of the fact that the sun is relatively weak. The winter is characterized by depends on how, frequency is sort of dependent on the year and how lucky we are. But we start to get these cold, low pressure systems that form in Alaska and kind of drop down into Northern California. That's when we get these cold fronts passing through. The flying days in the winter are sporadic, but they can be excellent when they happen. You just have to time your flying days right and have a little bit of luck in the process. And finally, spring, arguably the best paragliding and hang gliding weather that we have in the Bay Area. Spring is characterized by a strong lapse rate, which means generally reasonably good surface heating, and there's still some cold lingering air aloft. We still are under the influence of these lingering low pressure systems that are dropping down from Alaska. Marine inversions are weak but increasing as the season goes on. The other nice thing is that even as the atmosphere is starting to dry out, we still have hopefully a lot of lingering moisture in the ground from winter storms, which means we can actually see clouds where we're flying as opposed to blue skies like we have most of the year. In spring, I would say there are frequent good flying days, often the best ones of the season, but still you need a little bit of luck because it just doesn't happen every single day. So in summary, in terms of seasons, what we end up getting are three scenarios that make pretty much all of the Bay Area sites work well. The first ingredient that you need, or that leads to there being good flying in the Bay Area, is cold air aloft. As I mentioned, generally it's inverted here, but once we get that very cold air aloft, that overpowers the cold air or the cold surface temperature that's present from the cold Pacific waters, and we actually get some convection in the bay. The other scenario that generally seems to work fairly well for good flying days in the bay is a prolonged period of offshore flow, which ends up pushing all of the marine air out to sea, and it basically wipes out the inversion. So those really hot days that aren't too windy, those can actually be some really good flying days, but they're a little bit elusive. The third scenario, which can actually lead to some decent flying days in the summer as well, is when we have a very deep marine layer. The thing that characterizes that is that it's sharply capped by an inversion. So you may only get up to 3,000, 4,000 feet, just depending on how deep that marine inversion is. But even within that really deep marine layer, you will actually still get convection and can have some surprisingly decent flying days. So that's something that I think not a lot of people are necessarily aware of, like just thinking of summer as being always inverted. But if the inversion is high, you can actually have a lot of room to play underneath it. So keep an eye out for those days. Okay, so I think the next thing that we're going to go into here is a site analysis. Oops, that was a preview. So basically, the way that I've organized this section is I'm going to go into some details about the site, talk about some of the unique features that characterize each site, talk about what patterns to look for that make that particular site flyable, and also look at some patterns that make it not flyable or not great conditions. And the last thing we're going to look at for each site are some examples of some good flights that have been made from those particular sites. So the first one, Muscle Rock. That's basically it. If Shiggy's there, it's flyable. If he's not, there's probably something wrong. That's it. I'm half joking here. I actually intentionally didn't spend a lot of time in the coastal sites because there are a lot of complexities to the coastal sites, but it's also relatively simple. Generally, there's no drive or hike up involved with the site. If you're driving to Fort Funston or you're going to Muscle Rock, if you see wings in the air, if the wind is blowing straight west at 8 to 15 miles per hour or whatever it is, go fly. If it's not, don't. If there's time at the end, we can get into some of the coastal dynamics, but that's pretty much it for Muscle Rock. Yeah, he is. That's true. He's there even if it's not flyable. So maybe that's not accurate. Okay, so Ed Lebanon, probably the most popular site in the Bay Area just because it's accessible to everyone, and that is where most of the training here happens. So some features of Ed Lebanon. There are launches at 1950, 600, and 300 feet above ground level. The LZ is actually at around 500 or 600 feet, so add 600, 500 feet, whatever the exact amount is, to each of those launches to figure out exactly how high each launch is above sea level. So the things to note about Ed Lebanon are that the prominent features of Ed Lebanon generally face southwest. And there are a number of reasons why that's important. In the winter, the reason why a south-facing launch is important is because there is more sun exposure. Just because in the later months of the year, the sun is lower on the horizon. So anything that's south-facing is going to get more sun exposure for more of the day. Another thing to note about Ed Lebanon is that compression and the Venturi effect, which means when the wind is kind of funneled through a confined area, can lead to some surprisingly strong wind at lower elevations, and particularly in the landing zone. If you ever noticed that most training at Ed Lebanon happens in the mornings and kind of cuts off by noon, there's a reason for that. It's because it gets really windy and arguably sometimes even dangerous in the afternoon. So, when is Ed Lebanon flyable? So actually, more specifically, the way I split this up is into summer, and it doesn't necessarily mean June to September. It just means like the summer pattern, which could be present from like May-ish to September, and sometimes even like a summer-like pattern in October. But that's kind of how I think about summer in that sense. So generally, under a summer-like pattern, Ed Lebanon is mostly flyable early in the day when the local circulation pattern dominates. And before the stronger local mountain and valley winds pick up, and before what I've labeled as the bay flow, but it's that persistent north wind that just blows down the bay as the sea breeze starts to ramp up and that marine air starts to spill into the bay. So basically, if you're going to Ed Lebanon under a summer-like pattern, get there early, launch as soon as it seems launchable and you think you can stay up, because the window of opportunity is very likely to be limited before that north wind ends up coming in. The other pattern where Ed Lebanon can be flyable, it can actually be really good under a summer-like pattern, is when there is a very deep marine layer and there's southwest wind at the coast. The reason I mention deep marine layer and southwest wind at the coast is, well, let's think of the opposite scenario. If the marine layer is around 2,000 feet or less, remember, if we're thinking about the height of the coast ranges, generally what's happening at the coast is not necessarily indicative of what's happening inland. It's almost like two different air masses. Like there may be this eddy circulation where there's this counterclockwise flow out of the coast, but if it's squished under this 2,000-foot marine layer, what's happening in the bay is like, it's not necessarily related to what's happening at the coast. But I've experienced this a few times when it's this deep trophy pattern and the marine layer itself is 2,500, 3,000 feet deep or more, and you get this southwest flow that's happening at the coast. Some of that momentum seems to transfer into the bay, and you will actually get somewhat persistent southwest winds at Ed Lebanon, even midday. Inevitably, later in the afternoon, it'll switch to northwest once that stronger wind comes in. You can actually have a longer window of opportunity than you otherwise would if there actually is a very deep marine layer that's present. Outside of summer, basically anytime there's southwest, and even sometimes southeast wind, which is rare, but it does happen. That's generally a good day to go to Ed Lebanon. Make sure you're looking at the surface winds as well as winds aloft, because they're sometimes different. And the other interesting pattern that sometimes works at Ed Lebanon, but it's a little bit elusive, is when there is offshore flow, so the wind is actually blowing from east to west. In the morning, if you look at the windsock on the webcam, it'll be pointing backwards, not the right direction. But interestingly, if you look around 11, 12, 1 o'clock, the windsock will go limp, and it'll actually switch around. Even though the prevailing winds aloft are actually east, there will be enough local thermal activity that the winds at Ed Lebanon will actually switch, and you can fly there and stay up for a little bit. So that's when Ed Lebanon seems to be most flyable, but it's also good to know when it may be unflyable. So summer, as I mentioned before, pretty much midday onwards, don't go there. It's just going to be windy, it's going to be inverted, it's going to be turbulent. It's really not that great. Other seasons outside summer, basically anytime you have northerly winds or if it's stable and breezy, At 11 faces southwest. If the wind is north and the air is fairly stable, you're going to be in the lee. It's just going to be turbulent and probably unpleasant. Strong offshore flow, so if the wind is north or northeast and is blowing strongly and the windsock is pinned, you probably don't want to be there. But interestingly, sometimes the lower launches are actually completely isolated from whatever the flow aloft is. So for training purposes, if you're just looking to get a little sled ride off 300 or 600, it may actually be okay, even if the wind is strongly offshore. But your mileage may vary. Just be careful, because it could get really turbulent if it happens to mix down. So let's look at some examples of really interesting flights at 11. And I'm going to switch out of full screen here so we can look at these track clouds and the forecast discussions. Here. So this first example is a flight of mine. It's actually two flights. And if we look at the date here, this is June the 17th of 2018. So somewhat anomalous, because it was actually really late in the year. Like usually the good 11 days, like they're kind of done by May-ish, like before that summer light pattern sets in. But this day was really interesting because there were southwest winds, or south winds, I can't exactly remember what it was. And it was almost near the summer solstice, so there was really good ground heating combined with favorable wind conditions. So let's look at the forecast discussion, which is one of the main tools that I use, just to see what the conditions were like that day. I'm not going to read through the whole thing, but I'm just going to scan for some interesting keywords that kind of led me to believe that it was going to be a good day. So all of the historical forecast discussions are online, which is pretty incredible, and I've linked all of those at the end. So let's see what the forecast discussion here is saying. So the synopsis is that a low pressure trough over the west will provide cooler temperatures today. That sounds good to me. Especially inland areas which are expected to remain much cooler than normal. That also sounds really good, because if the forecast discussion is saying cooler temperatures than normal inland, but we're almost near the summer solstice, that probably means the surface is going to heat up, there's going to be cold air aloft, and it's going to be really good for flying. So these are some keywords that are already starting to make me excited here. Blah, blah, blah. I'm going to skip over the discussion here because it's not that relevant. What I'm actually going to do is look at the marine forecast, which is not something I necessarily look at for figuring out what the conditions are going to be like inland, but actually maybe I skipped something important here. There was I think it was the previous iteration of the forecast discussion was talking about a 3,000 foot marine layer, so that was another keyword that made me excited. So I figured 3,000 foot marine layer, let's see what the winds at the coast are saying. So Sunday, southerly winds will prevail over the nearshore waters as a weak area of low pressure sits over Northern California. Breezy conditions are expected north of Golden Gate this afternoon, with the rest of the coastal waters seeing relatively lighter winds. Sounds good to me. So let's go back. Forecast discussion sounds favorable. The next thing I'm going to look at is the 12Z sounding, which is at 5 a.m. the day of the flight. And let's see what that looks like. Again, this isn't a weather tools clinic. If you're not sure how to read sounding, plenty of resources online. But I'm just going to show you what I see here. That looks really good. The short summary of how to read sounding is if you look at the line on the right, which represents temperature, if this is roughly parallel to this green line here, or actually all of these green lines, which represent lines of constant temperature, that's generally good. This kink in the line here represents an inversion, which is pretty high, even for morning. This is, let's see, 700 and something meters. This is around like 1,000 meters or so. So even at 5 in the morning, the inversion's already at around 3,000 feet. So like this is a signature of a very good looking day for 11. We'll go to the 00Z sounding, which is the 5 p.m. sounding afterwards, just to verify that it was actually an epic day. But the other thing I'm going to look at is the Fort Ord profiler. If you're not sure what a profiler is, it's basically it's a instrument which is present at Fort Ord, which is pretty close to Marina and Sand City. And it's a way of gauging a real-time profile of the atmosphere, using lasers that basically shoot up into the atmosphere and then scatter, and you can actually measure the depth of the lower levels, or you can measure the depth and the temperature of the submarine there. So let's see what that looks like. The way to read this is the newest data is on the left, old data is on the right. The temperature in degrees Celsius is listed here. And these little flags here, let's see if I can zoom in a little. These little barbs here represent wind, and each one of these is 10 knots of wind. So let's, and I believe the time here is actually in, yeah, it's in Pacific time. So let's look around, let's say, 10 o'clock in the morning. It looks like the ground is starting to heat up. This is at 18 degrees Celsius. Let's look at 2,000 feet. That's like 12 degrees Celsius. That's really good. Warm surface temperature, cold air aloft, and you can see like the darker colors here are still showing some cold air aloft. The winds are maybe a little bit breezy out at the coast, but also earlier in the day it's still fairly light. Basically, this looks like a signature of a really good day with a really favorable atmospheric profile. So basically all of those components, the forecast discussion, the sounding, and the profile are all saying that it's a good Ed 11 day. So that's where I ended up. I actually ended up having 2 flights that day. This is the second one on my low performance A wing, where I was over like on the upper end of the wing with a big bubble inefficient harness. And this was one of my best, or personal best Ed 11 flights, where I ended up flying up to Mission, back to Ed 11, down almost to Alum Rock, and then all the way back to Ed 11 at the end, from the 600. And the flight before that was from the 300, getting up to about 3,800 feet, going up to Monument Peak and back, and then landing at the LZ to swap wings. Like, this is one of the better Ed 11 days. So that was pretty cool. The next example, this is actually Josh Cohen's flight from a couple weeks ago, where he flew from Ed 11 up to Pleasanton Ridge, up to Diablo, up to Discovery Bay, and then all the way back down past Byron, landing at Mountain House for almost a 100-kilometer flight. This is super impressive. I was flying the same day too, and it was interesting that I actually took a completely different route. I ended up going northeast, just sort of skirting around Livermore airspace and landing in the middle of the Altamont Pass. Whoops. But that ended up being a really good day. So same thing. Let's look at the forecast discussion and the soundings. And because of the favorable forecast, I ended up capturing some screenshots of the XC Skies forecast a couple days beforehand, just suspecting that this was going to be a really good day. So I can show you what the XC Skies forecast looked like before this actual day. What's that? This was September the 30th. Yeah. The day before this, Doug Hoffman flew from Ed 11 to Stockton also. So it was really good. Yeah, to Stockton. I'm not kidding. Okay, forecast discussion. So let's see. And there are a couple of these forecast discussions. I've just taken the 9 o'clock one because it seems to be pretty close to the time. Let's see. Partly cloudy and seasonable. Widespread rain appears likely. Nothing interesting there. I'm just trying to figure out where the interesting information is here. Here's a couple things here. Temperatures may actually warm a bit. Here's a keyword to look out for. Without a well-established marine layer. And this type of surface flow, look for the surfaces, look for the temperatures to warm, and it's talking about cooler conditions. Going to be a little short on time. I would recommend clicking on this and maybe looking at some of the previous forecast discussions, but you'll see that some of the key words about cold air aloft and generally south flow are going to be in place here. Okay. I think more interesting is going to be the sounding and the profiler from a couple days before. So let's look at the sounding. This is from the morning of. Generally looks pretty good. It's going up to 2,000 something feet. This is probably where cloud base was early in the day. And let's look at the sounding from the afternoon that day. Let's just hope that it loads. No. All right, we can't see the afternoon sanding, that's okay. I think looking at the profilers for this forecast is really interesting from 2 days prior as well as the day before and the day of, because you can really see the marine layer just getting completely obliterated here. So what am I looking at here? This is the profiler from 2 days before this really epic flight. We have some cool air at the surface. It's like a 2,000 foot marine layer. Orange and yellow, that's hot air above. So basically this yellow line here, that roughly represents the marine inversion. But you can see as time is going on, the inversion is lifting. It's getting higher and higher. It's starting from 2,000 feet. It's going up to almost 3,000 feet here. This is 2 days before. Let's look at 1 day prior. So here we go, and it's gone. The inversion has been completely wiped out. What happened here was, if you remember, there was that low pressure system. It brought some really nice clouds and some rain to the North Bay. But basically, the marine inversion got completely wiped out here, and now we have an unstable atmospheric profile. And further to the left, you can actually see there's even warm air at the surface, and now it's getting really unstable. So the marine layer has been completely wiped out. The last thing for this flight and this forecast is looking at XC skies. And I think this was 1 or 2 days before. If I could zoom in here. That's about as good as we're going to get. So this looks really good. This is at about 3,000 feet, 3,200 feet, give or take. You can see light southwest winds pretty much everywhere in the entire bay. And this is at 2 p.m. for Sunday, September 30th. Not only are there nice, pretty green colors here, which is indicating a high top of lift over the high terrain, but I think what's perhaps the most interesting is, I don't have the color scale here, unfortunately, but I think the light blue represents about 1,000 meters or so. Even the middle of the valley and over the south tip of the bay, there's actually a surprisingly high top of lift here. So the fact that I'm seeing these nice, pretty blue colors here is an indication that there's probably going to be really good lift everywhere with a lot of cold air aloft. So this is an indication of there being a really good day. All right, I think that's it for